person throws a stone horizontally at 15 meters per second. Then it hits the ground in 4.5 seconds. So what's the height of this cliff? So actually, the initial velocity isn't impacting how high it's going because it's being thrown perfectly horizontal. If it's thrown at an angle, then we need to take initial velocity into consideration. But right now, it's being thrown straight across in the horizontal direction, and gravity is pulling it down. So the only thing really impacting where the stone is going is by this classic quick little equation we have. I won't do negative 4.9 t squared, where 4.9 is the result of taking the acceleration due to gravity in meters per second and we divide it by 2. Okay, so that's where that 4.9 came from. So 4.9 is a number that's determined, it's based on the acceleration due to gravity, and it's in meters per second. If you wanted things in terms of feet per second, then you'd want to use 16. Okay, it's approximate equivalent. Shouldn't use those two words together. It's approximately equal to 4.9 meters per second. Okay, but we're talking about meters per second, so we're going to use 4.9, and then t squared. This is determining how far it falls after a certain amount of time. And again, the initial velocity isn't impacting how far it's falling. That only gravity is influencing that. So all you have to do is plug in 4.5 in for t, and then simplify, and that'll tell you how far this thing has fallen. So 4.5, I'm going to square that, and then times it by 4.9. So this thing has fallen 99.2 meters. Okay, so 99.2 meters is the height of this cliff, assuming we're going to ignore the fact that they're throwing it a little bit above the cliff. So 99.2.